Gentlemen. Just a very quick review of the four theorems we're going to use in chapter 6.5. I'm also going to attach this page to the assignment so that way you can have it to look at. And more importantly, I'm going to create a second video that goes over some specific examples. So the first one is called the triangle proportionality theorem. And it says basically that if you have this setup here where you have a triangle and then there's a line parallel to one of the sides like so, you basically now have similar triangles. You've got triangle RTU and triangle RQS are similar. And in addition to all the corresponding sides being in proportion, also in this chapter, they're telling you that the ratio of RT, which is this side, over TQ, which is that piece, is equal to the corresponding side on the other side, RU, over US. So you'll notice that QT and SU are both between the parallel lines, and you'll see that they're corresponding in the denominator, and RT and RU are on this side of the parallel lines, and they're in the numerator. So once again, if you compare the sides on this side of the triangle, RT over TQ, that's going to be equal to RU over US. So that's that theorem. The second theorem is the converse of that theorem, which basically means that if they're in proportion, so if the fractions are equal to each other, then the lines are parallel and the triangles would have to be similar to each other. So it's just the opposite of this. This says if the lines are parallel, the pieces of those sides are in proportion. And the other one says if the pieces of the sides are in proportion, then the lines are parallel. The third theorem down here says if you have three parallel lines and you have two lines that are intersecting those three parallel lines, kind of like a grid, okay, then you end up having these pieces here, UW and YW and VX and XZ, and they will be proportional. So the ratio of UW over WY, the ratio of this piece over this piece, is equivalent to this piece, VX, over XZ. It also works this way too, by the way. They don't do a separate theorem for this, but it would make sense that the ratio of UW, which is this piece up here, to its corresponding piece on the other side, VX, is equal to WY over XZ. So that's another way that they could have done it. And then last but not least, if you have an angle bisector, that angle bisector is going to create two pieces here. You've got the side of the triangle, AC, and then the piece it's attached to, AD. And then you've got this side of the triangle, BC, and the piece it's attached to, BD. And they're going to be in the same ratio with each other. So AD, the ratio of AD over BD is equal to the ratio of AC over BC. And once again, you also could compare, and this is the way I like to do it, you can also do it this way. AD over AC is equal to BD over BC. So we're going to do some examples of that, and hopefully it'll become clear on your assignment. Your homework assignment will be very similar to the problems that I give you for practice. So if you watch the video, you should be A-okay. All right, thanks.